Oh, yeah. 10-3A. My whole family is. It's really the only team we all agree on. The Kings. My parents like the Packers.
Aaron Rodgers is coming back to win the Super Bowl.
Okay. All right, here we go. We're going to do numerical statistics. So we did graphical statistics. We did some histograms. We did some pie charts, some bar graphs, stuff like that. Statistics. Numerical. All right. So now we're going to learn, and this is split up into 2 days, so we're not going to do it all numerical today. We're going to do numerical today and tomorrow. The thing that we are going to focus on today in statistics is letter A, distributions. How things are distributed between different sets of data points, okay? Now, there's all kinds of different shapes of distributions. You can have a symmetric, like a bell-shaped curve. You can have it skewed to the left, skewed to the right. You guys are always skewed. Whenever I do your statistics on like a math test, it's not like my Algebra 2 class. Okay, my Algebra 2 class, there's a lot of C's and there's some A's and there's some F's, right? But you guys, it's like most of you are A's and B's and then it kind of tapers off. So it's very skewed. There's the center, which is usually indicates typical measurement. Okay, usually, sometimes not. We're going to talk about standard deviation and all that tomorrow. What we're going to focus on mostly today is the median. And the median is just pretty much the middle, right? So you know your 3 M's in statistics? Mean, median, and mode. Yeah, you know them. Good. Median is like medium. You know how it's like small, medium, large? It's in the middle. Okay? So median, what you do is you list the numbers in order. Okay? And if the number of numbers that you're listing in order is odd, then all you do is you go to the middle number, and that's what the median is. The middle number. If those numbers that you've listed are even, not that the numbers are even, but there's an even amount of them, do you know what to do?
Just the mean average.
Perfect, yep. You take the average of the 2 middle ones. Okay, and we're going to learn how to do this by hand, and we're going to learn how to do this on our calculator too. So, let's start and let's do a median problem. Number 1. All right, we're going back to baseball. And we're going to Roger Maris. Oh, do I already have that in my... I do. I just put that in. Cool. Okay, so Roger Maris, he played some baseball from, I don't know when. Do you? Was it the 1950s?
I think it's the 70s.
70s? Oh, okay.
Totally guessing.
You're totally guessing? Let me find it.
Played with the Cardinals, right?
I have no idea. Where's Mr. Brass when you need him? All right, number 1. All right, it says find the median of the annual home run totals for Roger Maris's Major League career from 1957 to 1968. And it's in table 10.11 on page 700. All right, so this is what we're going to do. I'm going to turn to that. This is why I want you to have your books out. You have your book out on your iPad? So we're going to look at, I'll write it down, page 700, table 10.11. So go to 700 in your book, 10.11. There it is. Regular season home run statistics for Roger Maris. Bless you. He played from 1957 to 1968, and they're all right there. So this is what we're going to do. I'm not going to do that. We are going to list them in order from smallest to biggest. Okay? Do you have it open? Are you on that page? Oh, it's hard, though, when you take notes on your iPad, huh? Okay. Well, if you look at them, and we want to list them from smallest to biggest, 5 is the least amount of home runs that he hit. In his last season, 1968, he only hit 5 home runs. The next one would be what? 8, and then 9. Okay. And then he hit, what, 13, 14, 16. 13, 14, 16. After that was 23, 26, and 28. 28. And then the 30s was 33 and 39. 33 and 39. And then finally, one year, he hit 61 home runs. Wow.
It's wild. In 1960.
In 1961, he hit 61. Ah, there you go. That's a nice little stat. Yeah. Okay, so what you're going to do, we're going to find the median, not the average. We don't want to average these out. We're going to find the median. The median is in the middle, okay? In this case, though, we have an even amount of numbers here. And so we have to go to the middle of this stuff, pick the middle two. The middle two would be 16 and 23. You just count from either end, okay, until you get to the middle. So the median is going to be 16 plus 23 divided by 2. If you have your calculator, you can do that. Hit divide by 2, 19.5. Okay? 19.5. Now, you can't hit half a home run, but that's what statistics are. It's like when you have the average kid in the house, there's people that, and their average children that they have is 2.4. You can't have 0.4 of a child. Okay? Even people missing limbs, they're still whole people.
It's a double.
Yeah? Yes. Oh, yeah. You're going to miss all this, though.
Price. I'll get the video.
Okay. Okay. So that's just the basic, find the median. Now let's go ahead and we're going to talk about the next thing, which is the 5-number summary. Some of you have learned this and some of you haven't. Some of you learned it last year and you don't remember it. All right, the 5-number summary. Okay, these numbers are going to show us how widely things are varied, right? And you know this already? Is that why you're smiling? It's so cute. All right. So the range of your data points is to take the maximum and subtract the minimum. So for example, the quiz I gave in Algebra 2 yesterday. Someone got a 26 out of 25. That was the maximum. And someone got a 3. So what's the range? I'm kidding. I'm not kidding. Yes, that's the range. 23, right? That's huge. That means there are people who really understand. And there are people who don't. And there's a whole bunch in the middle that, you know, that's a big range. That's bad. You don't want a big range like that. Jerry, I know. It's sad. You need to start tutoring these kids. Come on. Okay. Then we're also going to have something called quartiles. Now, quartiles are really good to help us to see. We're going to get a bunch of data points, and we want to try and figure out what's going on here. The quartiles separate data into fourths. What you have for Q1 is quartile 1, okay? And quartile 1 is the median of the lower half of data. Median of the lower half. That's quartile 1. Then there's quartile 2, bless you, that we never call Q2 though. Q2 is just the median, okay? This is quartile 2, but we don't write it as Q2, we write it as the median. And then we have Q3. And Q3 is the median of the upper half. Do you remember this? And we're going to do this stuff on our calculator. Our calculator's going to do all this for us. It's so nice. You might have had to do this by hand. What do you mean?
You did Q1, median, Q3.
Mm-hmm.
What, could you go Q1, Q2,
No.
Q3?
They don't call it Q2. They call it the median. I don't know. I don't know. That's what they do in the book. I'm trying to be right. Okay. And then another number that they find very helpful and interesting is the IQR. And this is the interquartile range. Interquartile range. We're going to use that in order to find outliers. Like that 3, I hope that 3 is an outlier, you know. Like outliers are things that don't happen often. They're way outside of your main data. Okay, I'm hoping that 3 is an outlier. If not, then there's a whole bunch of people next to that 3, like a 4 and a 5 and a 6, which is actually true.
Were those actual numbers?
Yeah. It was A's and F's. I'm not kidding you. I'd like to graph that data. It was so, like this. It was bad. Okay, but the interquartile range is to take the median of the upper half minus the median of the lower half. It's just Q3 minus Q1. Okay? And what they want you to do is they want you to write this as a 5-number summary. And you write it like this. You put a little bracket, and you're going to list the minimum. That's going to be the smallest number in your set of data points. Then you're going to do Q1 is next, the median of the lower half. Then we're going to have the median in the middle, median middle, Q3, and then the max. That's called a 5-number summary. It's very important in the statistics realm. Okay? Now with this 5-number summary, we can list it as just numbers in brackets, but we can also list it graphically. And when you do this graphically, it's called a box and whisker plot. Okay, the hat kids are saying ew because they've seen this before. The algebra 2 kids are like, what are they talking about? It's okay, I'm going to explain it like no one's ever seen it. A box and whisker plot is this. You're going to have this box, and the bigger the box is, the bigger your interquartile range is. Okay? This first one right here, this right here is Q1, and this over here is Q3. And inside that box is going to be your median. And if your data skews more to the left, then it'll be closer to Q1. If your data skews more to the right, it'll be closer to Q3. So let's just put it somewhere around here. I don't want to put it in the middle. Sometimes it is in the middle, but I don't want you to think it's always in the middle. And that's going to be the median. Okay. Then this box is going to go out a certain number, and we're going to use the one that shows outliers. Okay, that's not going to the max and min necessarily, because sometimes you'll get a random dot on the outside of all this box and whisker plot thing. Okay, this right here is called an outlier. And I'm going to actually show you how to prove that it is an outlier, because you can't just say it's an outlier if you see it on your graph. It's kind of, yes, we're going to talk about that. All right, so let's go to our calculator now, number 2. And we're going to find the 5-number summary for Roger Maris's home runs, because we already have that data in our calculator. 5-number summary for Roger Maris's home runs. And we're also going to draw a box and whisker plot for this too. Okay? So, here we go. Go to your calculator. And hopefully stat, edit, you have all that in. Did you put that in? Yeah? Okay, I hope so, because I want you to try this with me on your calculator. Tristan, shout out to Tristan, he told me that you can actually sort these in order. Did you know that?
No.
I didn't. I'm super stoked on this. If you go over to stat, do you see that second one, sort A? You can go to sort A and then tell them to sort L1. L1 is second one. And then hit enter, and then it's done. And you're like, what's done? It's done. You go back to stat, edit, and they ordered these numbers for you. Isn't that cool? I don't have the right numbers in, though. I just noticed that. Do you guys have the right numbers in? No? I don't either. Let's put the right numbers in if you haven't already. All right, so you go to Stat, Calc, and we're going to do number 1. These are called one-variable statistics. Do you see 2 variables here? No, I have only L1. One-variable statistics. Now, some of you guys have this prompt, bless you, that says, you know, it gives you some questions. It's just one variable statistics. Hit enter, and it's going to give you a bunch of stuff that we're going to learn tomorrow. But it also tells me n equals 12, so ignore all this stuff. We're going to do that tomorrow. It says n equals 12, and I can arrow down. And then what it does is it gives me the 5-number summary. There it is. Okay? So the 5-number summary is 5, which is the minimum. We knew that. 5 was the least amount of home runs. Quartile 1 is 11. The median, see how they didn't even call it quartile 2. They call it the median is 19.5, which we found in number 1 by hand. 30.5 is the quartile 3, and the maximum is 61. So that's your 5-number summary for this data. Now,
Just sort it.
no, it doesn't have to be sorted. Now let's graph it. Okay, we're going to draw a box and whisker plot. So go to second y equals. Okay, choose that one. You probably still have it on histogram. Yeah, probably. So we're going to go to the type and look at which type we're going to. They actually have 2 types. And your book told you to avoid the second one here.
Is that what we want?
We want this one, the one where it's blinking, the one with dots. It says right here,
You can get an outline.
when we're finding the quartiles for data sets with, no, that's the wrong one. Some students may have learned to make simplified box plots that extend the whiskers all the way to the minimum and maximum. That's this one right here. These deprive us of important information about distribution and should be avoided. That's what it says. All right, so choose that one. Okay, L1. And then what you want to do is you want to make sure your plots are turned on for plot 1, and then hit zoom 9. Zoom 9, and there it is. Did you get it?
Yep.
Your box and whisker plot? Zoom 9. Zoom 9 is zoom stat. It'll take your statistics and put the right window for it. Zoom 9 is awesome. Did you ever learn about zoom 9 before?
Yeah.
I think Mr. Bexford made you do your window by hand.
Yeah.
I always say zoom 9.
Yeah, one of the ham kids last year.
Oh, told you?
me about Zoom 9.
I love zoom 9. All right, so then what we want to do is we want to draw this box and whisker plot. So what you can do here is you can actually trace it. If you hit trace, it has the minimum for you right here. The minimum is 5. And then you have your box. I went a little far. So you just draw it as best you can. It doesn't have to be perfect, but it's nice to state what each thing is down here. We have the numbers up here. That's 11. This is 19.5. This is 30.5. Now the interesting thing is, let's find out what's at the end of it. What's at the end of it? 39. How did they get that magic number? 39 is the number right before the outlier. That's an outlier, okay? We're going to prove that when I teach you how to prove that in just a minute. That dot out there. Because look at all of his data was in a nice thing, and then all of a sudden he had an outstanding year, right? It's like if you took a test and in all these chapters and you got an 83, an 81, a 79, a 76, and then you got 102%. That's kind of an outlier. Outliers can be good, but they can also be bad. Okay? All right, so there it is. So you just draw it like that. Do you guys remember this from last year, some of you? Remember it from this year? Did you do this year? Yeah? Oh, and stats, AP stats. Okay. All right, so now let's find out how to prove something is an outlier. So here's how you do the proof of an outlier. This is the way this book teaches it. I don't know if this is the same in the other books, but basically it says you're going to take 1.5, and you're going to multiply that times the inner quartile range. And that's going to be a special number. And so what you're going to do is you're going to take this number, okay, and if that number, if you take Q1 and you subtract, what should we call this number? What do you want to call it? X?
No. Y.
Y?
Yeah.
All right, we'll call it Y. We'll call it capital Y. If you take that number and you do Q1 minus that number, then anything below that is going to be an outlier. Okay?
No. Wait, how does that, like,
Yeah.
your IQR is just the maximum mid, right?
No, IQR is Q3 minus Q1.
Okay.
It's the inner quartile range.
Okay, so basically you're making like a, not a number family, but
Yeah, anything above that is going to be an outlier. So let's prove that 61's an outlier on this one, okay? We know it is. We can see it is. There's a dot out here showing that it's an outlier. So first we need to find what the IQR is. The interquartile range, it tells you the length of your box right there. It's going to be Q3 minus Q1. So in this case, Q3 was 30.5 minus 11. And the distance from 11 to 30.5 is 19.5, perfectly. That is the median. That's not always the median. I mean, they're not always the same, okay? It just happened to be here. Now we're going to go 1.5 times 19.5. Let's do that. 29.25. All right, so to see if there are any low outliers, the low ones on the low side, you take Q1 and you subtract 29.25. Well, that's not going to make any sense in this problem because what was Q1? 11. So this is 11 minus 29.25. We don't even care. That's going to be negative. He didn't hit any negative home runs, okay? The other one is to take Q3 and add 29.25. So Q3 was what, 30.5 plus 29.25? So the magic number here is 59.75. Anything bigger than that is an outlier. So you would say 61 is greater than 59.75, so it is an outlier. See, statistics is all about backing it up, isn't it? You have to back up your inferences. You have to back up anything that you say. If I say 61's an outlier, I can't just say 61's an outlier because my graph told me so. You have to prove it in a way. We just proved it. Whew! Aren't these good? Do you want to take stats next year now?
No.
Okay. Was that number 2? Yeah. All right, let's do number 3 now. Number 3.
How many are
Well, I did one with the other class, but it's the same stuff. I just used different statistics. It was about the age of people who are expected to live in South America countries. It was actually pretty interesting, but we won't do that one. Okay, I think this is the last one. Now, suppose that on a test, let's say that I'm giving a test in algebra, or quiz. I'm giving a quiz in Algebra 2. Okay? And for this quiz, I have a score, and then I have a frequency. Score and a frequency, okay? So, for example, let's say that 26. People got a 26 on this last quiz. You know what I'm going to do? We're going to kind of do it for this class. Which class should I pick? I'm going to pick first period. Oops, I didn't say that. There's some outliers. Terrific. They're terrific. I love them. So how many people? 1, 2, 3 people got a 26. Hey, that's pretty good. And we're not going to do them all because that would just take forever. 25. How many kids got a 25? 1. Nobody got a 24. 22. There were 4 kids who got a 22. You know what? I don't want to do this because the data. I'm just going to pretend. All right. 21. There were 8 kids who got a 21. 17. There were 4. There were 2 kids who got a 10. And then that one person who got a 3.
Is that an actual person who got a 3?
Yeah. Of course not. Not in my classes. I'm a great teacher. All right. So now, this is what you're going to do. You don't have to put into L1 26, 26, 26. Okay? You don't have to put 21 in 8 times. That would be a waste of time. So let me show you how you're going to do this. You're going to put this data in for L1 and this data in for L2. Whoa. Still one variable statistics, though. Our one variable is the score. This is just a frequency of them. So go to your calculator, clear out Roger Maris's home runs, and enter this data. All right, Matthew, you got it? You done? You quick? Same. Nope. They do need to match though, like L1 and L2. Okay, we're good? So we want to get a 5-number summary for this. We want to do a box and whisker plot. We want to do the whole shebang. What we're going to do is we're going to do stat, calculate. We're still doing one variable statistics. But some of you guys have what's called, it says statistics or whatever, L1, and then frequency, you'd put in L2 there. For me, my calculator, I do L1, comma L2. My calculator knows that L2 is the frequency of L1. So let's try it. Go to stat, calc, one variable statistics. I'm going to do L1, comma L2.
Why did you put it in your frequency list?
I don't have that. You do.
Yeah.
Yes. L2 for frequency list. Yeah. Then hit enter and see the number. That's how I can always tell if it's right. The number of people that took that quiz, there were 23 of them. Okay? That's how many people took the quiz, 23. And then we can list our 5-number summary. 3, 17, 21, 22, 26. 3, 17, 21, 22. These are nice numbers for just coming up with them, huh? Okay, there they are. 3 is our minimum, 26 is our maximum. This is Q1. Okay, that's the median of the low. See how far away that is from 3?
Yeah.
This 22 is Q3. The interquartile range is pretty small here. 22 minus 17. It's not a lot. And then let's go to, all of our stuff is all plugged in, right, for our graph. We can just hit zoom 9, and that'll give you the new box and whisker plot for this. Are there any outliers? Are they saying that 3 is not an outlier? Huh. Should we prove it? Let's see. Yes.
No.
Yes. No, I don't. All right. The interquartile range, 22 minus 17 is 5. Okay? 3 is definitely an outlier. Are they crazy? It says it's not, huh? It says it is?
Ricky says no. Ian says yes.
Do I have the right one?
I had the wrong number. My bad.
No, mine doesn't show that. Okay. Then I'm going to do 1.5 times 5. Uh-huh. 7.5.
Yes.
So I'm going to take Q1 and subtract 7.5 from it. So 17 minus 7.5 is what? 9.5. So anything below 9.5 is an outlier.
Oh, did you have it on the
Yeah.
wrong?
Mine doesn't have an outline.
Yours doesn't? Mine doesn't either.
Yeah.
I think I know what's happening.
What's happened?
On the graph, if you just do it like as we were doing it before, it doesn't do the frequency thing.
You have to add it in.
You do? Dang. Okay, so it showed that. Oh.
Wait,
How do you do that then?
I'm not sure.
Do you know, Ian?
On mine, I just pulled that.
You put it in L. Oh. So I just did a box and. Oh, I know. You're right. You're right. Okay. So go to second Y equals. See frequency? I didn't put L2 there. Aha. Thank you.
Yeah, it's an outlier.
Yes, so then it turns out to be an outlier. See, I knew something was wrong. You guys, you worked it out for me. You're so sweet. All right, zoom 9. Oops. Zoom 9. Ah, there it is. Yes. I knew that 3 was an outlier. All right, so here it is. Goes like that, goes like that, and then over here, and that must be 3.
Was
Okay.
3 an outlier on your real data?
Mm-hmm. Well, I didn't put in the 6s and the 5s and the 4s that showed up, though. This isn't really my real data. All right, so 9.5. And then anything that would be Q3 plus 7.5, anything higher than that. What was Q3? 22?
Yeah, so nothing.
So that would be, yeah, there's no way you can get a 29.5 on that quiz. 26 was the most you could get with the bonus. Okay, so 3 was our outlier. Cool. I'm so glad you said that, though, because I would have just kept going and not known. But, yeah. So when you do these, though, make sure that if you don't have a frequency list, because you're going to do, the first one you're going to do is just going to be L1 with no frequency list. Make sure you get rid of that. What was there? Was it just a 1?
Yeah.
Oh, whoops. A Y?
It was just one.
How do you get it to be 1?
Whoa, I don't know.
Oh, press another toy.
Whoa, why is it Y now?
Just tap alpha and then hit 1.
Alpha 1. Ah!
Because it's like alpha lock.
Yeah, it is alpha locked on there, isn't it? And then that will be, okay then. Yeah, that brings us back to the one that doesn't have a frequency list. So you got to be careful with that. Do you know what I mean? So if you have a frequency list, use it. If you don't, make sure you get rid of it. Okay.